All right, everyone, I think we're going to get started here. Looks like you're all settled into your seats. I hope the several breakout sessions have been an inspiring chance to connect and learn with action items lined up for when we leave this wonderful program. So I'm thrilled to be able to moderate this wonderful panel on AI in the natural resources space. We have an amazing group of experts sharing the stage with me. So I'm going to try to keep this intro short so we can really get into the substance. So California, its vast natural resources face converging and cascading climate change-driven challenges, including drought, wildfires, and other natural disasters, while maintaining bold goals to decarbonize the fifth largest economy in the world and conserve its diverse ecosystems. Tackling these huge, complicated problems, all while ensuring that the most vulnerable Californians are not left behind, will require mobilizing resources and partnerships across all levels of government. All levels of academia, all levels of industry, as well as other elements of the private sector, while developing and deploying new innovative technologies and jobs. Recent years have seen rapid and very public advancements in generative AI. Tools such as ChatGPT or Notebook LM or Claude have captured the public's interest in particular, but traditional AI tools, such as those that rely on machine learning, have continued to develop at incredible rates, offering unprecedented capacity to take on and tackle large-scale challenges. So when it comes to data analysis, predictive modeling, or even decision-making support, AI could be a powerful tool in the state's toolbox. When thinking about how to approach some of these problems, right, AI can be many different things depending on how we deploy it. So I'm joined here today, once again, by four incredible experts who all work in different areas where AI and the natural resources world collide. I'm going to invite each of them to introduce themselves to tell us briefly about their work, starting with Dr. Ilkay Altintas, Chief Data Science Officer at the San Diego Supercomputer Center and founder and director of WIFIRE at University of California, San Diego. All right, Dr. Altintas.
Thank you. I'm going to try to lean into this mic, so let me know if you can't hear me. As mentioned, I'm the Chief Data Science Officer at the San Diego Supercomputer Center, and this is my 24th year there. And since I started there, we've been working in the intersection of scientific computing data and its use in generating scientific knowledge through integration of multiple technologies. Over time, we've seen the shift from computing and simulation and large volumes of data to many forms of data coming together and integrating into the scientific process. And one of these areas early on was actually seeing the need for dynamic data integration, what we refer to as big data, into the wildfire space. So over the years, we developed methodologies to work with fire scientists and fire management to translate what's possible into solutions. But at the same time, we also developed the commons foundations like data and AI frameworks to enable everyone building around open data and open science so that we can enable new spaces for solutions and make equitable access to data, computing, and AI a part of the solution. So I think my points today will be from that point of view.
Thank you so much, Ilkay. Next on our expert panel is Dr. Nathaniel Roth, or Nate. He is the Chief Science and Data Advisor at the Department of Conservation here in Sacramento. Dr. Roth.
So it's an absolute pleasure to be here. It's great to see so many familiar and unfamiliar faces in the audience. The role of AI within natural resources here, well, I'll speak more specifically on the Department of Conservation, but I believe it true and generally around the state is still very much an evolving area. Not that it could be anything other than that. We're learning really as we go how to handle the massive influx of data that's coming in. We're struggling to make sense of it, to understand what lessons it has to teach us. We're in the very infancy of building the toolkits that we need to collaboratively use these data, to identify features within it, to start classifying characteristics across our landscapes or within other aspects of our data, to predict what those might mean for our future, to validate those incoming data streams, to identify, do we have errors coming in? And then importantly, particularly related to the emerging generative AI, to use these for effectively communicating outwards to policymakers, to the public, and with our peers. And we're having to do this within a framework that is challenging to do from a state. The state is not as nimble as we might like it to be a lot of the time. We have the use of terms and definitions, some of which we'll probably get into, that people may not understand fully, that start closing out or making it more difficult for us to access portions of what is now called AI, that 20 years ago was just a portion of a practice. So the conflation of AI and generative AI is something that we need to work on as a definitional standpoint to make sure that we don't close out our past use of tools and that we're able to effectively use those that are evolving, because there has never been a more important time to be able to build those insights from the data than right now. And it's an absolute pleasure to get to be with up here on stage with a number of the thought leaders on making that happen.
Thank you so much. Next on our stage is Dr. Bill Swartout, who is the Chief Science Officer at the USC Institute for Creative Technologies and co-director of the Center for Generative AI and Society.
Thank you. Well, it's great to be here. And I want to tell you just a little bit about the two organizations that I'm involved with. The first one, the Institute for Creative Technologies, is a Army-sponsored, university-affiliated research center. And it started about 25 years ago when the Department of Defense noticed that video games were getting to be pretty good. In fact, in some ways, they were better than the simulations that the military was spending millions of dollars on every year. And the idea was, would there be an advantage to getting a closer relationship between the Department of Defense and the entertainment industry? And so some studies were done, and basically the studies said, yes, this would be a good idea. So the ICT, the Institute for Creative Technologies, was set up as a kind of neutral meeting ground where these various rather disparate groups, the military, academia, and the entertainment industry could meet and work on projects. So we work on artificial intelligence, on creating virtual humans, on creating, on computer graphics, on virtual reality and augmented reality, and the learning sciences. And then we work with also people from the entertainment industry in order to create stories and characters that are engaging and compelling, with the idea of creating the next generation of systems for training and education. And I think where this becomes relevant for today is we've done work on creating simulations. For example, we have a simulation called Disaster Sim, and it's basically, think of it as a simulation for training people how to operate in a disaster. And it's done by creating scenarios that are engaging and present the kind of surprises that happen in a real-world experience, so that people can be trained about not just the sort of the book learning of how to handle a disaster, but also see operationally what are the issues that come up in that context. And we've also done a lot of work, and I'll talk more about that later, in virtual environments and virtual reality, and capturing worlds that are out there and creating then models of them in the computer. The other center that I'm involved with, the Center for Generative AI and Society, is concerned not so much with generating the next version of ChatGPT, but instead looking at how generative AI is going to impact society. And there are two areas that we've begun to focus on. One, since we're in Southern California, is generative AI and the entertainment industry. And that's being run out of the School of Cinema at USC. The other group that I'm involved with is looking at maybe the other area that has been most impacted by generative AI, which is education. And we're looking at how can you use generative AI productively. There's been a lot of press, of course, about all the potential dangers of generative AI in education, and papers like, the term paper is dead, have been written. But we're looking at how can you use it productively to actually improve education for students. So I'll leave it with that.
Wonderful. And finally, we have Dr. Varadharajan, who serves as Earth staff scientist at the Lawrence Berkeley National Lab. Charles.
Thank you. I'm very excited to be here with this panel. So I am a computational earth scientist, and I lead the Earth AI and Data program at Berkeley Lab. My research, I'm an AI user, so I use various AI technologies for water, energy, and climate applications that are sponsored by the Department of Energy, which spans a range of areas, including water resources and water quality. I've worked on methane cycling, as well as the environmental impacts of carbon sequestration and fossil fuel production. I also have done a lot of work on data management and data integration, and bringing in data together to be able to mine all that information. So I'm a big advocate of open data and open science, and I am a PI for a DOE environmental data repository called ESS Dive, where we make our DOE's data actually publicly available and freely available to anybody to use. So in my work, I've actually worked with both the CCST as well as various California agencies such as the Department of Water Resources in terms of various studies that we've done in the past, including on well stimulation, as well as on water data and thinking about AB 1755 and how to make our water data openly accessible and available. So I'm really happy to be here and I'll talk about a little bit some of my applications of my work later on. So.
Wonderful. Thank you, all four. Before we dive into questions here on the stage, I wanted to inspire all of you to start thinking of your own questions, as we'll hold about 15 minutes for those of you on Zoom, as well as those of you in the room. If you are in the room, please feel free to raise your hand, and staff here at CNRA or CCST will provide you that note card. Thank you so much, McKenna. If you're on Zoom, please feel free to place your questions via the Zoom screen. With that out of the way, let's start with a broad question. So we've already heard a little bit about your work, but I'd really like to hear from you. What I'd really like to hear from you is what you see as the most promising AI applications for addressing California's challenges in the natural resources space.
I guess I'll lead off. It's not an easy answer because there's so much. A couple of my pet ideas, the places that I really think would benefit the state moving forward, include a lot of the integration of multiple data sets that Ilkay mentioned. Building more complete representations of the full presence of the state, physical in terms of 3D, procedural in terms of how processes may be linked to each other, so that we can better understand and have kind of a virtual platform for testing how our actions on the landscapes may propagate the systems and the processes across the state. Similarly, the data feeds that we've got coming in from Internet of Things, from the sensors we have across the landscape that help us monitor the landscape. We must use tools such as this to understand when we've got anomalous events or ones that we should be paying more attention to. that are crossing that we ought to be attaching a human to follow up on it. There's a great example right now. I mean, Alert California is a poster child for how to make this a piece of the process and to be able to identify and react more quickly to events in darn near real time.
I agree. I think the fire cameras and the AIs that are deployable on them is an amazing example of what can be done if we put data and open data with open AI approaches together and integrate it into the operational practice. That's the most important part of it, actually. So I'll take a little step back from what can be done and how it can be done, how can we be more methodical about it, because I see data and technology just like anything else, a tool. And it needs to be really to be useful in the context of California in the operational and traditional knowledge, and looking at the objectives of what we have at hand and understanding what are the gaps, what are the challenges we can actually address through better use of data and science and technology that integrates both of them. So that's in a way how we are using AI in this space. And as you said, one of the biggest use of AI that's probably not that obvious in general is to create new insights that are knowledge. I teach beginning level data science, and to my students, what I'll say is you start with data. If you add structure to it, it becomes information. Then if you start contextualizing that information in the context of a problem or science or a domain or expertise, that becomes knowledge. But knowledge is actually just knowledge, and that's what science does, that's what AI does. And how do we then use AI and understanding of what we know the problems are, and then generate wisdom out of it? In that data chain, basically wisdom is, can you use that knowledge to generate insights that you can actually drive better decisions or help communities and public? And I think one of the things that we need to do is to bring that cultural and conventional knowledge and context into data to use AI better. Once we start doing that and find communities of practice, for instance, that help us to define what are the problems and how could those tools be used in the context of those problems, I think then any area will need AI. So I can't even pick that's how age-old industries are being transformed.
I'll mention a couple of things that we're doing. One is in the area of virtual reality. Actually, they're both in the area of virtual reality. You have things like Google Earth that allows you to see a representation of the space anywhere on Earth. Problem with Google Earth, of course, is that some of the maps are a few years old because they haven't scanned it recently. If you're in a situation of a natural disaster, or wildfire, say, the Earth is not going to look anything like it was a year ago at the places that have been affected. Yet, it's important for managers to know what's going on and what's the truth on the ground. Where are the hot spots? Where are the issues? With AI technology and the decreasing cost and yet increasing power of processors, it's now possible to do things like fly a drone or a set of drones out over an area, capture the area using photogrammetry or other more advanced techniques, and then build very quickly a 3D model of that space that managers can navigate and view. And furthermore, again, using AI, it's possible to identify different aspects in the terrain, like vegetation is here, this is dirt, this is water, or this is possibly a hotspot that you need to attend to. And that kind of technology is now at the point where it can be put into a backpack the whole thing, the drone, the laptop that analyzes and so forth. So this really opens up the opportunity, I think, to make available much more broadly the kinds of technologies that used to only be available on a very high-end basis. The other kind of related thing that I wanted to talk about is a project that we're doing on, you can think of it as Google Docs for VR. Google Docs, you can have a bunch of people all working on the same document, and they can all see the changes that everybody made. Now, imagine that you have a team of people who are going out into some area, some landscape, and they want to gather information about it. Well, it's possible to set things up so that they can all either be wearing headsets or just using augmented reality on their phones or on a tablet, make annotations about particular things that they're seeing, and everybody else who's on the team will see the same annotations that they're making. So you can have a shared picture that you very rapidly can put together. You don't have to wait till everybody comes back and reports out what they saw and forgot this or that. But you've got a dynamic picture, and somebody who's in a more central command post kind of situation could see the whole picture as it's evolving. So just a couple of things that, these are the kinds of things that I think advances in machine learning, advances in processors, advances in virtual reality and augmented reality headsets are going to make possible.
Right, so I think there's many things that I heard this morning in the panels about what the state needs in terms of natural resources management that AI can really help with. And the things that excite me about AI are things that we can do now that we could not have done before using traditional approaches. I think that's what's getting the world excited about it. So the first one is, I would say, the use of computer vision to extract information from the vast amounts of geospatial data that we have. We heard about some of the remote sensing, such as the airborne snow observatory measurements. We heard about drones, or even things like historical maps. So I can give you a concrete example of some work, actually a paper that we're hoping will come out very soon, where we've been able to use a computer vision model that actually is able to identify from historical maps orphaned wells. So these are undocumented orphan wells where we don't know where they are. There are hundreds of thousands of them potentially in the US. And we've been able to look at these maps and use these pre-trained models that are already out there that we didn't have to develop from scratch, but we were able to fine-tune it for our application and then identify these locations. And there's about, on the order of about 500 of them, including in a couple counties in LA and Kern counties. So this is something that was not possible at all before with traditional signal processing approaches. The second, I'd say that other aspects of generative AI is starting to think about downscaling some of the climate data products that would be very relevant for decision making. So if you're trying to make a decision on very fine resolutions and you have these coarse resolution climate products, say even your future climate projections, or even some of these large scale products at 1 kilometer scale, and you need something at 10 meter scale, you could start to think about AI as bridging those scales and being able to downscale. So there's super resolution methods using AI that are starting to emerge. The next thing I would say is the use of large language models such as ChatGPT to automate processes and to make things very fast that was previously manually intensive and very labor intensive. So I'll give you another set of examples of work we're doing. So this project on this undocumented orphan wells is called Catalog, sponsored by DOE with 5 national labs, and some of our national lab partners and our team are looking at extracting historical from well records some data that's missing in state databases. So we're starting to classify forms, and we're starting to pull out some information that can help the states populate their databases. So, and hoping that all of this will convert to practical tools that the states can continue to use in the future after the program's over. The other thing we're using, exploring the use of large language models for is for data management. So the repository that I mentioned, we have a lot of people contributing data in various ways. They're not standardized. There's a lot of missing metadata. It's hard to make them easily searchable and discoverable, and we're trying to use LLMs for helping us discover this data more easily, but also augment some of the missing information so that we can make those data more reusable by other people in the future. And then the third space I think is really exciting is the space of forecasting and predictions. I heard about the water supply predictions this morning on atmospheric rivers. One of my colleagues, our director, Bill Collins, has a project called Cascade, where he's partnering with NVIDIA as well as our DOE Supercomputing Center, NERSC, to actually run climate models, but at large, very, very large ensembles, so that we're now able to identify some very extreme weather events, like the extreme Pacific Northwest heat wave, or some of these extreme hurricanes, as well as atmospheric rivers. And that was not possible before because, previously you could only run a few hundreds of climate model ensembles. Because you can make machine learning surrogates of actual models, you can now run tens of thousands of ensembles. I think they just hit the 10,000 simulation mark. And that is the order of magnitude of ensembles at which you actually need to identify extreme weather events. The other thing that I've been doing in my research is using traditional deep learning approaches for widespread spatiotemporal predictions of water resources. So for example, only 1% of our streams are gauged, and even fewer for other water quality variables. So this is a big problem for us in water resources management. And so we've been very successful at using deep learning methods to predict in unmonitored basins river flows as well as river water quality, stream temperatures at widespread scales, at continental scales. And we're able to find that these models are doing these predictions and getting much more accurate results than even local models that are built for very specific locations. So I think all of these are very exciting, but also very relevant for California's natural resources management.
Thank you all so much. I mean, we're living in a world where the capabilities of AI tools seem to be just accelerating. But where are there still the data needs that continue to limit, right, the application of such AI tools? And Charo, thank you for touching on the fact that, right, we are using AI to improve, right, the use of AI, right, which is just a very elegant twist. But would love to know from each of you, right, if you had a magic wand, right, what of those limitations would you eliminate?
Okay, I would start because especially in California, groundwater data is a huge gap. We were actually a few years ago building some models for groundwater level forecasting in California and finding significant data gaps, including you need predictors of changing groundwater levels, so where's the pumping and where's some of this other, even just water table data at high resolution is sort of something that's missing, right? So I think there's a lot of the monitoring, it's expensive to do monitoring, and there's not enough of it. So we're pretty much in a sparse data realm. Even though everybody talks about a lot of data, for a lot of our applications, we are literally limited by data. But the hope, actually, that I find with our predictions in unmonitored regions modeling is that what we realize is you don't need 20 years of continuous monitoring data. Even if you have a little bit, you can start to use these models, and what you need is data for validation, at least for a few scenarios, and even that can help. So even if you can only afford to put a sensor out there for 1 year, that's better than having nothing available. So you could potentially think about moving your sensors around to optimize, your data collection. It doesn't necessarily have to be a static network that monitors something for 20 years. So that might be a thought. And I'd say that data quality is also very, very important. These models are data-driven models. So it's garbage in, garbage out, literally. It's very, very important to have high-quality data. So when you have data that's not necessarily been curated very well, or you don't necessarily trust because you see all these outliers, you see the warts in the data, you don't want to use it. Machine learning people like to use products that are out there that are beautifully curated, that's easy for them to use, right? You don't want to spend years just putting the data together in order to run your model. You want the data products to be easily found, download, and then use it. So most of the data, I find, especially the academic sector, people use things not because they make sense, but because they're easy. And so you use a lot of benchmark data sets to keep improving your model, but that's not going to help you solve a real problem. You need real data. And for that, the agencies, I think, have a really important role in being able to put good quality, curated data sets out there for us to be able to use in AI.
Same. So thank you. The validation information was one of the first ones on my list. Along with that, I would add that think of how much we've demonstrated we can start to accomplish now with data that is essentially pulled from collections that were collected for other sets of purposes, not for large-scale evaluations. And if we start to systematically collect comprehensive data sets over space and over time that are data rich at the best qualities that we can, the engine that we can build on top of those could be really, really remarkable.
I think one of the things that we've run into in our work, and it's been actually more with the military, so I'm not sure how much of this carries over, but there are often significant bureaucratic issues in getting access to data. And I think if agencies can think about how they can facilitate that rather than putting up roadblocks, that would be a huge help. Now, that may just be a problem in the military, but it's certainly a problem that we've run into more than once, I will say. And often there are situations where we know there's a nice trove of information out there, but actually getting at it is really a problem. And I think that there needs to be sort of a mind shift that we need to try to facilitate that, because there will be significant benefits that accrue from that.
Yeah, I think why data and AI? Because AI learns from data, but what kind of data AI learns from is important. And I think we live actually in a data-rich time. So it's not about lack of data, but as my other fellow panelists said, it's about the challenges related to that data and exposing and trusting that data. Because when you put something in the society, and everything we are talking about is putting AI in societal systems in the context of something. So that requires building trustworthy data sets and building a process. And what are the challenges for it? It starts with, as you said, silos of data. And they come with healthy bureaucracies for good or bad reasons, or for no reason at times. But there's generally a reason, and figuring out that reason and finding if we can actually link this silo to something. It doesn't have to be broken. Nothing has to be broken. Things can live in enterprise systems, but how do we create knowledge systems that can link these silos and data agreements, standards to link things with each other and create almost ConOps for data in general. And the other part of it is, of course, within that lack of infrastructure, we don't have well-defined processes for how data gets acquired, who owns it, what's its life cycle, how it gets shared. There are many issues there, including legal frameworks around data. And when we talk about data in the government space, it needs to be open. It needs to be open. Doesn't mean everything goes. It needs to have some set of standards associated to its use. It starts with, of course, the basics, which is very hard already: findability, accessibility, interoperability, reusability of data. I think we are past the times when we talk about AI that we acquire data for a reason and it sits there. It doesn't get used for anything else. We need to expose it for whatever else it's useful for, both economically, but also in terms of public need to actually have that transparency. The other part of this is, I think, the lack of collaborative models. This breaks the competitive collaborative models, and it requires a collaborative approach to actually work together, because it's very cross-disciplinary when we talk about AI, and we need convergence of the minds to build solutions, new forms of public-private partnerships, new forms of actually maintaining open things through, both venture cycles, and also big tech can have a role in this. So there's so many pockets of challenges when it concerns data and infrastructure related to that. We need new working models for it to really be impactful. And, last principles I'll say about data is definitely data sovereignty, especially when it concerns tribal nations and other groups who are often vulnerable to issues of having their data exposed in different ways. And privacy of those data and sovereignty is not about just the people. It's about the culture, it's about the land. These are environmental issues. And when we think about land as a private entity, our look at how we actually open and share and put governance around data changes. And over time, we noticed also there is this concept of our data is open too. Here, go download it, it's accessible. That's not open data. That's actually, it's accessible and useful for some reasons, but data needs to come with some standards around its usability, its timeliness, its interpretability, and things like navigability of data and in different scales and environments. So these are all AI issues, actually, and they lead to better use of data. Maybe they don't lead to direct insights, but through that, we can generate more insights.
I hear again and again that the innovations in data science, AI, machine learning must be in parallel, right, advanced with innovations in process. Right, to have that implementation mindset to better understand how it actually fits. Thank you all so much. Moving on to workforce development, right? We are talking about, right, preparing a workforce for jobs we can't even imagine yet. So I would love to hear from the four of you, right? How do we go about, right, securing the future with a workforce capable of tackling these issues?
I think, from my perspective, I think one of the things that we really need as a country to embark on is getting AI literacy to everybody. In other words, upskilling the workforce so that everybody, not that everybody's going to become a Python programmer, but everybody needs to have a general awareness of what AI is, what it can do, what are the issues surrounding it, how, in general terms, it works. I think that kind of knowledge is really going to be necessary to prepare people for the jobs of the 21st century. And AI, as we're seeing with generative AI, and when it unfolded, how potentially, I think it hasn't completely happened yet, but potentially it will impact an awful lot of different career paths. And if we work things right, people will be able to take the new jobs that it opens up, and actually it can significantly increase productivity. If we do things poorly, there will be a lot of problems. So I think getting people so that they understand what AI is just really essential. And it also, I think, from the standpoint of our democracy, is really important because It will allow citizens to be better educated about the important issues that are going to be coming before us as AI continues to evolve.
So a big part of this is innovation and talent development need to go together. We can't have innovation without talent development related to that innovation, and AI particularly accelerates innovation. And having access to data, equitable access to resources, and it includes also for communities and students to have access to things they could do AI with, having the training data, AI-ready data sets together with their training data, having computing environments to actually do the AIs with the right libraries, and having sandboxing settings that we could actually explore with AI in different settings. These are all important for new upskilling, as you said, and talent development approaches. And the other thing is about being able to look at data. So public understanding what AI is. Data itself is a very abstract concept. Right? When we say data, we all probably understand different things here. And when it comes to the public eye and data being exposed to them, to people who are not used to looking at data in those different ways, having public settings in museums or other settings, like experiencing AI and data for natural resources through those AIs, I think is a good communication and training tool.
So it's easy to say that we need to ensure that we have a pipeline for folks that have the technical skills to implement AI, whether it's the model training or the validation. But what I think reaches even beyond that and is probably the more difficult skill set to cultivate really is that of being a critical thinker. We need to build that in. You need every time, and this is true regardless of whether it's AI or most any other scientific endeavor, is to be able to look at it, identify where the weaknesses are, what are the biases, either implicit or explicit, within the process that's being done, and what does that mean for the application of those bits that you've learned to the real world. In close partnership with that, and I think this is something that we've admitted, at least historically, certainly in my training from the university course loads, really was more of the ethics. Where do I start running into situations where I am likely to do more harm than good, or do serious harm to a set of folks that it is imperative that we avoid? I think those are components of building a workforce, particularly that critical thinking and that ethical basis, that are probably the ones that we need to focus on more than the technical skills, because those will come. But the critical thinking and the ethical approach to the use and application of these tools are going to be key to our future.
If I could just jump in here. I think, so building on that, I think one of the things that's interesting is that while AI, in a sense, is presenting us with this education problem of, we've got to get people skilled, it also is presenting us with an opportunity, because it's possible to use AI to build tools for teaching that make students better learners and instructors better teachers. And so we can build, using AI, virtual mentors who may be based on real people that can discuss with you ethical issues in AI, in appropriate or intelligent tutoring systems, using, and these can be significantly augmented from over what they used to be, using the natural language capabilities that are now embodied in generative AI. So I think it's interesting that AI is both creating a problem, but also presenting an opportunity, again, if we navigate it correctly.
Yeah, so AI, training in AI is a challenge because the technologies are like evolving so rapidly, such that even those of us who are in the space, you think you've learned something and then like a month later there's a new version of some new model that you have to start learning all over again. So it's a continual learning experience, and you actually have to intentionally dedicate time to keep on top of the technologies. But that's for people who are sort of in the space and developing methods and using AI on a day-to-day basis. And I think we have to sort of think about two tracks of training, and one for people who are like that, who are doing this as their jobs and really thinking about using AI for whatever application. And it's really important there, I think, to have people with domain knowledge, be engaging with the people who are developing the computational tools. Fortunately, because I'm in a national lab, we do have sort of that team science approach where we work with computational scientists, and I find the hardest thing is to translate our problem into a mathematical thing that they can solve, right? So to figure out how we can partner with them in a way that they can develop solutions that address our problem is really important, and having the technical background, both for them from the domain side, but for us from the computational side, to know what's possible to do, right? So you're not just dreaming up some wish list. This is something that you can practically use to solve a real problem. I'd say sort of there's now the shift towards what ChatGPT and all these other generative AI tools have done is they've kind of almost democratized AI in a way that almost every user, like my son, can now go to ChatGPT and ask a question, right? So you really do not need to be an AI expert to start using AI these days. And in that case, there's a very different set of training, like what was alluded to by the other panelists, where you need to now understand what the risks are of using AI, where these models hallucinate. They can make things up. You need a human in the loop to verify your results. You have to start thinking about when is it safe to use, how do you use it safely, what's the right appropriate usage of AI, which is very different from how do we develop AI applications, for which I would say, we do need people with computational training, and if universities could make sure that their students are like trained for coding as a sort of a basic requirement, that would really help. But nowadays, ChatGPT can write your Python code for you, right? So I think we need to think about both sides, sort of the non-expert users as well as sort of the expert users.
I had the same thought, Charles, in that we don't need to become Python coders, because now, right, the natural language prompts are writing our Python code for us. How quickly this is all changing. I have one more question before we turn it to you all to pose your questions, both on Zoom as well as in the auditorium. And this question is about trust and trustworthiness. So when we incorporate these models into decision-making, whether that has to do with hazard mitigation and risk assessment or resource management, how do we ensure transparency and accountability in these processes?
I think it's really important to have the data that's being used for training openly available, having the source data. That's something that people can find and use, as well as to have the models that are used also openly available. I'm a big believer in both open source code as well as open data, so people can replicate that work. But now I would say that that's becoming more and more challenging with the growth of these models and how industry is sort of very rapidly developing these very large models. You need an extraordinary amount of compute to run them, as well as they're using so much data that it's hard to know, and it's continually being updated, right? So it's hard to know they're being trained on and how these models are, what they're actually being run on. So that interpretability and trust is a challenge, and that's, I think, why we need more efforts on the validation and the verification, and having humans being able to vet the results and seeing if that's, at least testing it for known things that you know the answers for, and seeing if it's at least being able to do the right things when you know the answers at the very minimum.
Yeah, just to build on that, I think one of the things that where there's a real need is in developing techniques that allow us to produce answers with greater assurance that they're correct. And let me give you an example of that. If you just ask the plain old ChatGPT to give you an answer, you don't really know when it's answering the question how much data went into the particular answer that it's producing. And where ChatGPT generally gets into trouble is if it goes into an area where it doesn't have a lot of data. That's when it tends to hallucinate, because it doesn't really know, or it doesn't have a lot of experience from the data as to what's likely to be right. And it gives you what it thinks is the most likely answer, and that may be plausible, but it's not necessarily correct. On the other hand, if you take an approach where you say, okay, we've got this content that we know is accurate, and what we're going to rely on ChatGPT to do is to selectively summarize portions of this or present portions of this, then you're much more likely to get a valid answer. So that's just one example of how you can do that. There are other techniques as well.
Yeah, just to quickly respond to that, sorry. One thing I think that we don't do enough, but we should more in the machine learning world, is doing uncertainty quantification. There's a very rich field in traditional modeling of doing UQ, which is what uncertainty quantification stands for. But in machine learning world, we tend to put out deterministic results. And I think just being able to do that, like, you know, in the sort of the scientific aspect of verifying language, but we could do this with our models. We know how to do this, running your ensembles, running things that you know help you predict the full range of spread and not just one result, I think is another way of like handling this, just to build on what you just said.
Sorry? I think that the simple form of the answer to this is that it's much the same as the practices we should be using with most any other modeling activity, at least within the modeling space. That's as previously mentioned, the open data, the well-described methods that are being used, validation of the outputs against real world. One thing I'd add to it, descriptions of sort of the envelope that the modeling was developed on, so that you know you can start to understand the outer bounds of appropriate spaces to ask it to make predictions in. I think the evolution of a clear set of statements on what appropriate uses of these tools may be from the developer's perspective, who have a better understanding than anyone else on, okay, here's my intent with it. Here are the areas where I know that it's going to be stronger. Here are the areas that I know that are going to be weaker. And here are the areas, either space or time or subject matter, where we have no treatment, no testing of it, and we do not have any way to verify whether it's going to give good answers or not. And therefore, we can specifically tell you, hey, don't base decisions unless you stay within this general environment that we built the model to start answering questions on.
Transparency is a spectrum or a continuum. It's like it could be completely white box or completely black box approach, and there's a whole lot of colors in the middle that's called shades of gray. That didn't sound right. So the black box is what we see today. So the AIs that we interact with, including ChatGPT, are extremely black box approaches. We don't know what went into these models. We don't know why they're generating those results. We know they are probabilistic models, and what we are seeing is there's a high probability of those things being close to each other, and it's just stringing them together. So I personally either use ChatGPT for humor, I ask it questions to laugh, or sometimes, if I'm being really blocked, as a starting point, not the end point, right? So in that sense, it's not valuable. If you want trust out of a system, if you want precision out of a system, these things are extremely useless. And how do we make them useful? Bringing our actually knowledge and transparency to these systems. At the minimum, we should know what data went into a system to be actually trust and use it, call it transparent, what kind of techniques they are building on. You don't have to see the full thing. You need to be able to explain how things got together. And right now, actually, there are a lot of progress. There's a lot of progress going on in the generative AI and other types of AI and explainability and interpretability, but we are still in the wild, wild west. There's a lot of, let's just throw this out there and test it and what it's going to cause. So that narrative around AI is going to kill humanity. AI will not kill humanity. These are just systems. They are learning from examples, and just like us. But what will be really problematic is this, right? Not having transparent AI and not having regulations on how they're being used. So transparency, I think, should be at least a measure of how we are deploying systems. If we don't understand what we are deploying, uncertainty quantification exists for reasons, sensitivity analysis exists for reasons, because when you start stringing things together, you go to a danger zone. NASA, right? You can't shoot that rocket off using these systems. So when things require high precision or, more trust, I think we need to build AIs based on really data we trust in the first place.
Thank you all so much for engaging in this conversation on stage. I understand that we have a few questions I'd love to get to. I realize we're already after the top of the hour. We did start about 10 minutes late, so I do want to go for about 5, maybe even 10 minutes further, eating into our mixer time, I realize. But for all of those who have a hard stop, obviously feel free to leave through the back of the auditorium. But I would like to hand it over to my colleagues, Jason and John, Jason, John, and John Thompson, to please reflect the questions from the audience as well as from our Zoom audience.
Oh, thank you so much. Just a reminder, if anyone in the audience does have any questions, if you want to raise your hand, one of our team will bring down a note card. If we can't get to it right now, since we do have some limited time, we'll at least be able to pass it on to our panelists and hopefully try to address it in another way. We do have one question that came in. All of you, or we did have a few questions that came in, but one of them, you all touched at some point on concerns with data governance or quality control. Is there an opportunity to use AI to actually help with some data sets with actually correcting some of that or organizing the data, or what would be some of the challenges involved in that?
Yeah, I can take a first pass at that because it's something we've been thinking about for quite a bit of time. So data, there's various aspects of data quality all the way from the source. So it starts with the sensors or wherever you're getting your data from, and ensuring that those, just making sure the instrumentation works in the field, because there's nothing you can do to correct bad data if it's bad from the source. So you can do a little bit, but not as much. So I'd say investing in our monitoring infrastructure itself is important. But once the data, we've been doing a lot of work on using anomaly detection approaches for outlier detection and identifying bad data points. We've been doing gap filling approaches. So some of these machine learning, especially the newer generative AI, but even the traditional approaches are good for gap filling. So that's always been a challenge, is having, almost very few data streams are fully complete. And then we've been thinking about using AI both in terms of, metadata curation as well as for data integration. So we actually just have a new project at the lab that's kicking off on trying to harmonize the various ways in which people, label their data, their columns, and how do you start to integrate data because someone just labeled it differently, but it's essentially the same thing. So those kinds of, ways in which you can both integrate as well as quality control your data are, I think, some possible ways that are very practical and doable nowadays.
One of the other things that I'd like to toss out within this area is there's validation. I mean, there's the gap filling. There is understanding whether you might be having a sensor problem within the data set and detecting it so you can appropriately treat those data. We've also speculated at various points, because we have a fair number of data sets that are coming in, and these probably don't count as the large data, but they're data sets coming in from human and other sources, and identifying and potentially adapting to biases that may be within sort of the human